A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So let's walk through this. You can see here that I have a quadrilateral. It's inscribed in this circle. You can see that each angle is technically an inscribed angle, right? Each angle has the vertex on the circle, and then the sides contain chords of the circle. So let's talk about one angle at a time. So if I talk about inscribed angle EDG, and then this angle EFG, I notice that this angle EDG intercepts this arc over here. So its angle measure would be half of that arc. And then EFG intercepts, let's pick a different color, this arc over here, which means this angle EFG would be half of that arc's measure. Both of these arcs together are 360 degrees. So that means that these two angle measures together should be equal to half of that, or 180 degrees. So these two opposite angles are supplementary. So angle D and angle F, their measures added together are 180 degrees. Just like the opposite angles E and G, those should also add up to 180 degrees. So that's what we call supplementary. So again, opposite angles for the inscribed quadrilateral are supplementary. So we have two examples here, and it asks for us to find the value of all variables. So what I notice here is I have an inscribed quadrilateral, right? All angles are inscribed in the circle. So that means that opposite angles, so angle S and angle Q, are supplementary, which means that 4y minus 1, the angle measure of S, and 65 degrees, if I add those together, it should equal 180 degrees. So I can solve this equation for y. 4y and then negative 1 plus 65, so that would be plus 64 equals 180. So if I take 64 away from both sides, then that means 4y would equal 116. And then dividing both sides by 4, we get that y would equal 29. In the same fashion, we can solve for x. We have angle P and angle R. These are opposite angles. So that means that 63 plus 3x, those should be supplementary. So they add up to 180. So if I take 63 away from both sides, 180 minus 63 is 117. Then I can divide both sides by 3, and 117 divided by 3 is 39. So that means x equals 39. In the next problem, we're looking for x over here, part of this angle being 4x, and then this angle is 7y. So we're still looking for an x and a y. So the first thing that I notice here is that this angle, where I have the 4x, so angle C, this is my inscribed angle, and it intercepts this arc. So in order for me to solve for 4x, I need to know what this entire arc is, because I know that this angle C would be half of that measure. So I notice that arc AD is 84 degrees, arc DC is 80 degrees, arc CB is 150 degrees, 52 degrees. So if I can find the measure of arc AB, then I'll be able to figure out the measure of arc DB. So if I take 360 degrees and subtract 84, 80, and 152, I'll figure out what's left over for the measure of arc AB, which is going to be 44 degrees. So I could go through and I could say that now that 84 and 44 are both labeled here, then I know that this entire arc, arc DB, is going to be 84 plus 44, which is what? 84 plus 44 is 128. So the measure of arc DB is 128 degrees. So I know that 4x, this angle here, should be half of the measure of this intercepted arc. So 1/2 of 128 degrees. So 4x equals half of 128 is going to be 64. And if I divide both sides by 4, that means that we get x equals 16. This isn't the only way to do this problem, but it is one way. We can also look for the measure of y. So I'm going to erase some things here just so I can highlight different things for you. So now I have angle ADC, which is 7y degrees. This intercepts this arc here, arc ABC. So I know that this angle should be half of that arc's measure. So the measure of arc ABC is 44 plus 152. That's going to be 196 degrees. So that means that this angle, 7y, should be half of 196 degrees. So 196 degrees is 98. So 7y equals 98. If I divide both sides by 7, then that means y equals 14. So the leftover space on your paper is for you to do the work for your skills check.